In this video, we'll be learning how to do teen mathematics and specifically implicit differentiation. So in calculus, we use implicit differentiation when we can't represent the derivative in a standard conventional form, which is f prime of x equals some value. That's how we typically or most commonly write derivatives. But in the case of, let's say, questions with multiple variables, such as x squared y plus, let's say, 3y equals 4, we can see that we can't show the derivative of the equation in solely in terms of f prime x. That's not an option here. So this is where we can use implicit differentiation to find an answer. So basically, in implicit differentiation, it's similar to regular differentiation, except whenever you take the derivative of y, you'd also include dy over dx. So let's find the derivative of this equation and see how we can do that. So here we'll first, since there's two algebraic expressions, we'll have to use the product rule for this first expression right here. So we have 2x times y plus x squared. And since we're taking the derivative of y, now we'd replace y. Instead of just having 1, because the derivative of y is just 1, we'd instead replace 1 with, we would keep 1, but we don't need to explicitly write that because we know 1 times anything is the same value. So we just write dy over dx. And then let's solve for the other two terms. So 3y again, so the derivative of that would just be 3 and the y goes away. But in implicit differentiation, we'd also, since we found the derivative of y, we have to include dy over dx. And according to the constant rule, that's just 4 just becomes 0. So now we have to rearrange this equation so that all the terms including dy over dx are on one side and the rest of the terms are on the other side. So we can see that there's only one term right here that's doesn't include dy over dx, so we just bring it to the other side. So we have now x squared dy over dx plus 3 dy over dx equals negative 2xy. Now we just need to extract whatever terms, whatever the coefficients are from dy over dx, so we can isolate that term and solve for it. So it's just basically basic algebraic manipulation. So if we take out dy over dx, we end up with x squared plus 3 equals negative 2xy. And then the next step is pretty self-explanatory. We just divide this by both sides, and then we'd wind up with the derivative of the equation, or dy over dx equals negative 2xy over x squared plus 3. And that's basically how you do implicit differentiation. Thank you.